Geo-Surface Quick Start Guide Part 9, creating a tile drainage design using Geo-Surface Designer. In this tutorial, we will attempt to design a tile drainage system to target some low areas in this field that are prone to drowning. We'll look to place a main running north-south with the outlet at the north end. Then we'll determine whether the proposed layout is viable by testing the runs. Using the HD elevation and flow mapping layers, we can see the general flow trends that helped us visualize the rough design. We can also see some steep ridges that won't need drainage, so we can tailor the design to account for those. So first, we'll draw the main or header pipe, positioning it just offset from the bottom of the watercourse to prevent erosion issues. I'll set a target depth offset of 48 inches, ensuring enough depth for lateral connections. This way, laterals can tee into the top of the pipe rather than the sides. Next, I'll define the minimum and maximum depth parameters to confirm the run fits within the allowed range. And I'll also set the minimum grade to 0.1% to maintain proper drainage flow. Next, let's draw the first lateral. We'll start at the outlet end of the main and draw the lateral from its outlet, working uphill. I'll set the offset depth to 28 inches, assuming we're using a 4-inch pipe. And I want to keep at least 24 inches of soil cover above it. Well, once we apply the best fit grade, we can see that the connection shows green, which means everything looks good so far. We'll use the offset new line tool to create copies of the original lateral, spacing them every 120 feet. Since these are exact copies of the original line, we'll need to trim both ends of each new line. First, we'll remove the segments pointing toward the hills to the east, where drainage isn't needed. Then we'll trim the lines closer to the main so they can be detected as valid connections. Remember, the start of each lateral must be within 25 feet of the main line to be recognized as a connection. Now, when we toggle back to the main line, we should see 5 new connections. Because we haven't assigned any best fit grade lines yet, they still appear as black dots and are currently positioned at ground level. Next, I'll go ahead and add best fit grades to each of the new laterals. Now, each lateral has a best fit line assigned, and I've also added 24-inch offsets to all of them. In the drop-down menu, we can see that all the line names are green, indicating valid connections. And when we open the main line profile again, we can now see that all the connections are displayed as green dots sitting just above the main line. In fact, in this case, we can probably make the main shallower, which means less digging for our start holes. I'll reduce the offset on the main by about a foot, just enough so that the lateral connections still sit slightly above it. Let's add a few more laterals to the end of the main. We can either draw them manually or use the offset tool again to speed things up. Once they're added, we'll need to trim them back to avoid tiling through the ridge, which we don't want. It's always a good idea to save backups regularly as you work on any project. With Geo-Surface, it's super easy. Just click on Save Project to save the latest version as a JSON file. That way you'll always have a backup to go back to if needed. If something happens and you need to refresh the page, or if you want to take a break and come back later, simply load your project back up to restore all your lines and their parameters. Keep in mind the HD elevation and flow maps aren't saved with the backup, only your design is, but don't worry, you can quickly recreate them in just a few clicks and pick up right where you left off. We'll finish up the design by adding the last few runs and turn one of the laterals into a sub-main. Again, we need to validate that all our connections are valid and everything looks good. This field was a smooth design, everything worked without issues, but if we had an invalid connection, you'd see an alert like this. In this example, we could try making the submain deeper to fit the lateral, but that would make the connection to the main too deep. The better solution is to reduce the depth of the lateral, say from 24 inches to around 22. It's not ideal, but it's a safer option than over-deepening mains and submains. As a final step, let's determine the required diameter for our main line. Using the measure tool, we can estimate the drainage area. In this case, it's about 38 acres. Then, checking the main line statistics, we see the average gradient is around 0.6%. Be sure to save your project before leaving the page. Next, go to the Tools menu on the website and open the Tile Sizing Calculator. Enter the area, slope, and your desired drainage coefficient. For this example, I'm planning to use single wall pipe with a target drainage coefficient of 3/8 of an inch per day. Based on that, I can use an 8-inch single wall main to meet the requirement. And of course, you can also export image versions of your design for easy display. These can be used in GIS software or imported into Ditch Assist as a georeferenced image. You can also export the design lines as KML files, which can be viewed or shared using Google Earth or most GIS programs. And of course, if you email or WhatsApp the project file to yourself and open it on your mobile device, you can view the design in the field and use geolocation to easily follow the required run locations to help you get the installation exactly as you designed it.